I first want to show you my channel at YouTube. If you go to YouTube, you go to YouTube, you type Arjuno, and you click on my name. One of the playlists is for you guys, Summer 20, m227. Okay. Yesterday, for some strange reason, when I do the recording, I record it to my computer, so it doesn't show up on your cloud now. And I think, you know what, I will post it on YouTube anyway. So in case you don't find that on the cloud recording, you can find it on YouTube. Okay. Yeah, I try to keep the one on my YouTube more complete. Let me see. So this is the one on YouTube. And if you go to Canvas, it will be here. So some people still ask me, Thomas, how to get the recording. Then you go to Zoom. And then you go to cloud recording. Okay, now the thing is, again, yesterday when I did the recording, I happened to record it on my computer instead of on cloud. So I cannot post, I don't know how to post it back to the cloud. So I put it at YouTube. Okay, so if you don't find it here at the cloud recording in Zoom, you go to YouTube. Okay, and at the same time, I myself try to make it complete at YouTube too. That way, then you don't need to go to Zoom first to get the lecture video. Now, mind you that the one at YouTube has no subtitle. Okay, so if you need subtitle, then I guess you need to come to the cloud recording one. Okay, and okay, it's 8:01 already, so I can really formally start the class. I need to remind you that we have one homework due, the quiz 0. It will do this Saturday, and I will have one homework. I will call that quiz 1. I will post one more quiz maybe after the class or maybe tonight, and it will do on Monday. Okay, it's more than 24 hours, so don't worry about it. Okay, but so that you know which material that we use, and that will be up to the one today. Okay, let's start with the lesson. Okay, today we will do a couple things. First one, I will first interpret intuitive interpretation of the mean that we did yesterday. Okay, now what does it mean? It's basically like this. Let me show you by picture first, okay, graphically. Now, suppose you have some data, right? Now you have seen, what's that? Histogram, right? From chapter 2, I guess. You have seen histogram from chapter 2. So let's say the data is distributed this way. I just make more, yeah. This is one way to interpret that term, okay? So not the only way, but one way to do that. Now, suppose we have histogram, and at the bottom here, let's say this is 27 years old, 28 years old, 29 years old, 30 years old, and 31 years old, let's say. Now then, suppose we say we find the mean. Now, what does the mean mean? Okay, let's say the mean is 28 something. Let's say the mean is here. Let's say the mean is here. Let's say the mean is suppose the mean is 28.2. I just make up numbers, okay? Now, what does it mean to say it's 28.2? Okay, it means the following. It means if you imagine this this graphic here as the stack of books, for example, right? So there's a lot of books here, and that you stack them up. It's with some weight, right? And the weight are uniform, okay? But like 28 is taller, 29 is a bit less, 31 is the shortest, right? Now then, it means if you want to put these stacks of books on a beam, a very, very strong beam, and you want to carry that, okay, you want to carry this book all at once, okay? Now then, where should you hold the book such that you can carry them? If you can choose only one point to carry the book, okay, what point will that be such that this book, all of this will be balanced and you can carry them all at once? Now that refers, the X bar refers to that point, okay? The X bar that we have earlier, okay? Now that's the point you use to hold all the stacks of the books and at the same time still balance, okay? Now, you can try to see the following thing here. Take a look at me. It's kind of very, very rare you see my face. Okay. Now, suppose this is my the data, okay, which I represent by like a little pamphlet here, okay, booklet to be more precise. Okay. Now, then the mean of this book is the point that I can use. The point that I can use to support the whole booklet. Only one point, I can choose one point. The point I use to support the whole booklet and at the same time still balance. Now that's the mean, okay? So if I can choose one point from this book, if I can only choose, there are a lot of zillions of points here, right? Okay, if I can choose only one point on this book that I can use to carry the whole booklet, which point will that be? Now, the point that gives you, the point that enable us to hold this booklet at one single point and still balance, you can interpret that as the mean, okay? Physically, we call that center of mass. So don't underestimate the mean, the meaning of mean that we use here. It has a lot to do with what we do in physics. Okay. In fact, I want to say that there are things in physics that being used in statistics. Okay, and actually recently we have even more situation where statistic works. Things that we do here is being used in physics. Okay, especially when it comes to computation and quantum mechanics, those things. Okay. Now that's one a way to take a look at the mean. So coming back to this picture, suppose we have a stack of some masses here, okay? At what point I need to use on this line, at what point that I use on this line here, between 27 to 31, where should I put my finger? Or where should I put my, my pole such that I can hold the whole structure and still balance? Okay, now imagine if instead I put my finger here, right? Then the book will tilt to the left. While if I put my finger here, if I hold the whole structure here, then the whole structure, the whole stacks of this book will tilt to the right and fall down, right? Okay, now then the mean is the place where I need to put to support it such that I can support the whole structure and it's not tilting to the left or to the right. Okay, now that's what it means to be the mean. If you remember, if you are lucky enough that you have some interaction with your dad, like I did, okay? For example, when I was a little kid, my dad played with me. We play what you call that, seesaw, right? Okay, seesaw. So my dad sitting here and a small Thomas sitting there, right? Now, then the fulcrum, okay, the pivot, the fulcrum is actually the mean. Okay, the fulcrum is actually the mean. Why? Because for me to be able to play with my dad, the moment, the left-hand side moment, that's the physics terminology, left-hand side moment, which is the weight of my dad multiplied by the distance here, let me write it down, the weight of my dad multiplied by the distance should be equal to the weight of Thomas, a small Thomas, multiplied by the distance. Okay, now imagine if instead you put the fulcrum right in the middle. If this thing here, you put it in the middle. Let's say you put it here. Okay. Now, what happened is then the moment on the left-hand side will be a lot higher compared to the moment on the right-hand side. Because Thomas' weight, for sure, is much less than his dad's weight at that time, right? So what will happen if that's the case, then Thomas' dad will always be at the bottom and little Thomas will be at the top all the time. And there's no way you can play with that, right? Okay, so the fulcrum that you have, it doesn't have to be your dad, it could be somebody that you play with, right? Okay, now any difference of weight will create imbalance. Okay. Now, of course, if your weight only little difference, then you can play with your foot, right? Okay, your foot will adjust that, or you kind of like move a little bit forward or a little bit backward. If you have pretty much the same weight, if you play with your friend at the same age and almost the same weight. Okay, but imagine little Thomas and Thomas' dad. Okay, now then let's say if I put more to be more concrete, suppose my dad at that time is 180 pounds and Thomas' weight, let's say, was 30 pounds. Okay, you see that my dad's weight is approximately 6 times more, right? Which means for me to be able to play this seesaw together with her, together with him, then the distance from me to the fulcrum, it's supposed to be 6 times the distance from my dad to fulcrum. Okay, let's say this is 1 meter here, and this has to be 6 meters. So 180 times 1 equals to 30 times 6. Okay, now then again, this fulcrum here has to be located right at the point where the left-hand side and right-hand side balance and able to support both of us. Okay, now that's one interpretation of mean. Okay, Now, so going back to our data, suppose we have a data like yesterday, I think yesterday or a couple of days ago, we have the data 23, 19, 24, 21, and another 19. So, and let's say this is a sample. Then the sample mean will be, numerically, the sample mean will be the sum over the count, right? That's 40, another 43, that's 83, 106. 106 divided by 5, that will be 21.2. Okay, so if I need to choose one number to represent the whole data set, I will use 21.2. Why? Because 21.2 will represent the whole data set in a balanced way. Okay, now going back to this structure here, especially this graphical point of view here. Notice that then the mean must be, the mean for sure, between the smallest data to the largest data, right? Okay. You cannot have data between 27 to 31 and then suddenly your mean is actually 25. No, no way. The mean has to be between the smallest data to the largest data. By the way, the smallest data in stats usually denoted by lowercase m for minimum, and the largest data in a data set is usually denoted by capital M, which is the maximum. Give me a second. I need yours. Yesterday, somebody sent me an email about my daughter. She is 5 months old, and she's currently crying. Now, can you hear her?
Yeah.
Yeah. Is it loud?
It's okay.
Is it, can you still hear me?
Yeah.
Yeah, the fact that you answer my question actually means that you still can, you can hear my question. Now, because one of students actually brought up that issue that, Thomas, it's your voice is clear, but it was to the point of the baby's noise, to the point of annoying. So I told my wife, like, in case that she's crying, please move her to the second floor. Okay, but please let me know if it becomes not clear. Okay, this is the first time somebody actually brought this up though, but I still want you to be able to hear me clearly. Okay, yeah. Now coming back here, and yeah, keep in mind that the mean has to be between the smallest and the largest. Okay, yeah. So from here you see, right? So imagine if you have some package coming from Amazon Prime. Okay, let's say that package look like this. Okay, and then you need to carry this using one hand only. You will not carry that here, right? Okay, no, you will not carry that here. You, of course, definitely you will not carry it there. You will you will put your hand somewhere here, right? Oh, thank you, Benjamin. Oh, yes, thank you. I try to reduce the distraction because, yes, please understand my situation, but at the same time, I myself as your instructor, I will try to provide you an environment that you can learn from, okay? But thank you for your encouragement, Benjamin. Yeah, suppose you have Amazon Prime package coming, right? And then you need to carry that. It turns out that you have only one hand available. Then, of course, you will put your hand somewhere here, right? Now, your hand, on the other hand, is not a point. Your hand is actually quite big, right? Okay, so maybe the center of mass, the mean, in statistics, we call that the mean. In physics, we call that center of mass. Let's say the mean is here, then it will be okay. Yeah, as long as the mean is within your hand, then it will be okay. Right? And once you put your hand somewhere and the package tilt, then you know the center of mass is not there. Okay? But by the way, I would like to actually tell you something quite important. I usually mention this to my other class, so I would like to mention that to you too. Do you know where's our center of mass? Where is the center of mass of your body? Not your stomach, okay? Not your stomach. It's here. Okay, let me show you. I need to stand up though.
I don't want to see it. Bro,
You see me?
what is he trying to show?
Your center of mass is actually here. Not right
Huh.
in the middle. Well, our body seems to be symmetric, right? Okay, but we are actually, the center of mass is actually around your heart.
I like the pajama.
The bottom of your heart. Hello? Somebody say something? Okay, let me go back to share. No, I guess not yet. So what I want to say, your body has center of mass. Your body, the center of mass of your body is slightly below your heart. If this is your heart, it will be at the bottom of that. Okay. Now, and we are lucky that our center of mass is actually there. Of course, depends on how you move your hand. If your main hand is like too big or low, then it may change somewhere, right? But it's not too far from that point. Now, and we should be happy that that's our center of mass, because your heart is the only organ in your body that works actually for your whole life, right? If you think about it, right? If you think about it, the only organ that actually works non-stop for your life is your heart. Okay, now so repeat again. Somebody say something. Such that if your heart has to be working that hard, a lot harder than you, trust me, you still get some rest, right? Okay, but your heart working actually since you were in your mom's belly until you pass away, until we pass away, right? Okay, now imagine that this is our body. It doesn't look, it looks more like a what, turtle? I'm sorry. Yeah. Okay, your heart is here. Your heart is here. Okay. And the center of mass is approximately in this area, in this region. Depends on how you move your hand and your feet. Okay. Now, the thing is, your heart's job is to pump blood to other places, right? Okay. Now, the thing is, the further your heart from the center of mass, from the mean, then it will take more effort to do the pumping. You see? Now, good thing that it's very close to your center of mass, right? It's very close to your center of mass. In fact, it's your center of mass, such that the effort is actually a lot less. Okay, the effort is a lot less. One way to see the center of mass of your body is this. This is quite strange. This is quite strange. Now, you see earlier I point at the center of mass here. No, I don't want this. I'm sorry. This is not correct. This is not what I want. I want you to be able to see me only, and I don't know how to do it. How to do that? Well, anyway, I will just go. Okay. I told you that the center of mass is somewhere here, right? Okay. Now, if you want to locate that easily, one thing you can do is you hang it one way. You hang it one way and draw the line against the gravity. Okay, draw the line against the gravity. Now then hang it another way from another corner, draw the line against the gravity. Now, the intersection of those two lines will be your center of mass. Okay, now, so if you want to know your center of mass, the one way you can do is you actually hold to a rope, one hand, then you will see your body will be tilted, right? And using another hand, your body will be tilted. Now, the intersection of those two lines against gravity will be your center of mass. Okay, now that's a simple way to estimate the position of your center of mass. Okay, now coming back here, I hope that explains something about the mean. Now we go on further. So what is variance? Variance is a measurement that is hard to explain to you because your background, I have to assume your background is only intermediate algebra, algebra 2. But let's see the purpose. The purpose of variance is to measure the variation, how the data, how much the data set varies. Now, try to imagine these two sets of data. Let's say Thomas took 3 tests and his test score is, let's say, 65, 75, and then 70. And let's say my twin, I don't have a twin, but I just call that my twin. And then my twin has 50, that's a very bad score. So the second test he studied so hard, he got 90 for the second test. And once he feels like, you know what, currently I'm passing, so I slack off a little bit and I end up with 70. Now notice that the mean for these 3 test score, both 70. Both 70. Okay, you can add them and divide by 3. Okay, that comes from the sum. Let me just work it out. So this is 210 divided by 3, that's 70. Okay, and this one here, when I add them and then divide by 3, I still get 70. But if you take a look on how the data being distributed, let's say this is the 70, okay, this is 65, and this is 75. That's for Thomas distribution. For Tom's distribution, try to compare that with how Tim's grade being distributed. 70, 50, and 90. So you see Tim's scores is actually spread, has more variation compared to Thomas. You see what I mean? Okay, they have the same averages though. Okay, both Tom and Tim have the mean, the average 70. Okay, now so suppose, let's say this is the test score for test 1 and test 2 and test 3. And Tom asks his professor, okay, sir, my mean right now is 70. I know I'm passing with a C. I'm passing with a C. Do you think I will pass the class? Now notice that the variation is so small. It's small enough such that the professor may say that, yeah, you are currently passing and very likely you pass the class. Okay, now notice that even though these two guys have the same mean, but Tim, if Tim asks the same question, he may get different answer. Okay, why? Well, he's currently passing 70 points. Okay, so does he have a chance to pass the class? Yes. Does he have a chance to get the B? Maybe I write it down. Probability to get a B, which is 80 or more, is higher for team. Do you see that? Okay, because at least team at one point get a 90. Okay, that's barely A, but very high B if you don't want to call that B. It's B that's already A in my class, right? While Tom never get 90, Tom never get even a B. In all three tests, he got 65, 70, 75 for Tom. Never get an A, never get a B, okay? But at the same time, Tom never failed the test, right? So while Tim has higher chance than Tom to get a B, at the same time, Tim also have a higher chance to get a D, or if actually I should say to get an F. The probability to get F, which is less than 63, is higher for Tim also. So you see, because of the bigger variation Tim has, then even though Tim has higher chance to get a B, he at the same time, he also have higher chance to fail the class. Okay, now keep in mind, in this situation, both Tim and Tom has the same mean. But if we use these data sets, each one of them's data set to predict the future, then more things can happen for Tim compared to Tom. So if you ask me who Thomas will have more confidence to pass the class, I would say Tom has more chance to pass the class compared to Tim. Okay, but because Tim's scores very small, right? But at the same time, who has higher chance to actually get a B? Tim. Tim has higher chance. Now, apply this idea into stock market. Apply this idea to stock market. Suppose you have a stock named Tom, okay? And the average price from last year is 65, 2 years ago is 75, actually 2 years ago 65, last year 75, and right now is 70, okay? Now, will you buy this stock compared to if you have another stock that looks like 50, 90, 70. Okay, so you will see that the mean are both 70. This is not the right way to apply the variance, but I hope you see what I'm trying to say. Is that even though they have the same mean, but the variance here for Tom is greater than the variance for Tim. I'm sorry, it's the other way around. It's less than. Variance for Tom is less than the variance for Tim. Okay, now so if this is the case, which stock will you buy? Which stock will you buy? Well, depends on how close you are to retirement. Depends on how soon you need your fund that you invest in stocks to be available for you to use. If you actually, later on, I hope you have a chance to invest in some fund, which means you need to be a bit richer, okay? Yeah, either through your retirement, Roth IRA, 401k, and you do investment, then you will see your financial advisor will tell you the following. If you are still young, let's say 40 years old or less, they tend to tell you to get stocks that's has higher variations. Higher variations implies higher risk, but higher risk comes with higher chance to make more money. Okay, while if you are closer to your retirement and you don't want the stock market suddenly fall down and you lose all your retirement. So they will tell you to get the stocks or mutual funds that is more stable. So we usually then rely more on the dividend. So the stock price not increasing that fast, okay, but the dividend is stable, and it's usually for stocks like McDonald's, GE, Edison, I don't know, okay, and for the stocks that actually fluctuates more, you depends on the stock price or mutual fund price. Okay, yeah, that's so depends on which right you want to utilize to make the money. Okay, so dividend, if the stock price is quite stable, then you tend to rely on the dividend. Usually the company already mature, they don't really have a big room to expand, but they are very well needed. On the other hand, for the company whose stocks as fluctuates, usually they're at the beginning, they have plenty of room to improve. So most of the money they have, they will use to buy more infrastructure for the company. Then what happened is the dividend tend to be small, but the stock price depends on the valuation of that company. Okay, now that's what variance for. Now let's see how we compute variance. As we have seen yesterday, the formula for variance, population variance, the formula for population variance, let's say for example, we have this data set, the one that we had earlier. What's that? Let me use this. Let me use this. But this time I call that population. Okay, let's say this is my data set. Okay, and then we have compute. Again, this is so suppose this is population. So the population mean was, what's that mean? 106. Yeah, 106 divided by 5. That's 21.2. You see, right? 21.2. I wrote up here. Yeah. Okay. Now that's the mean. Now the definition formula for population variance. Let me say it first. What is the following definition is not really correct. That's not correct. But let me borrow this terminology first. The definition for population variance can be understood as the mean of squared errors. Now, first, what is error? Error refers to the difference between the data and the mean. So the errors for this population are 23 minus 21.2. That's the first error from here. 23 minus 21.2. The second error is 19 minus 21.2. 24 minus 21.2. 21 minus 21.2, and 19 minus 21.2. Those are the errors. Okay, if I compute that, that would be 1.8, negative 2.2, and then 2.8, negative 0.2, negative 2.2, if you compute each one of them. Now then squared errors is the square of those errors. Is 1.8 squared, negative 2.2 squared. Now, by the way, negative numbers, when you square it, it will become positive, right? Okay, 2.8 squared, negative 0.2 squared, negative 2.2 squared, which if we use calculator, that will be 1.8 squared, that's 3.24. You don't need to write this down. I just try to show you what the definition means. 2.2 squared is 4.84. 2.8 squared is 7.84. This is 0.04. This is 4.84. Those are the squared errors. Now the variance following that definition is the mean of these square errors. The mean of square errors. Yes, I'm not going to send you these notes, but I will post it on our discussion board for the day. The discussion board for the day is here. This is the discussion board for the day. Now, like yesterday's, I post the lecture notes and the lecture video. Okay, and 2 days ago, oh, where's that? Yeah, 2 days ago, the first day of our class, the lecture notes and the lecture videos. Okay, yeah, well, that's where I will post it. Yeah, I just need you to follow what is this definition of variance? The mean of those square errors, the mean of these, okay, the mean of these, which implies the variance is whatever the sum 3.24 plus 4.84 plus 7.84 plus 0.04 plus 4.84 all over divided by 5. Okay, 3.24 plus 4.84 plus 7.84 plus 0.04. I get 20.81. No, it should not be. Oh, 20.8, my bad. 20.8 divided by 5, which will be 4.16. Okay, that's the meaning of variance. The procedure is quite long now. Yeah, the procedure is quite long, even though for only a population size of 5. You will see this definition formula is rarely used when it comes to the real computation. And in my class, you will not compute it this way. Okay, don't compute it this way. Why? This definition formula is very prone to rounding error. It's very, very prone to rounding error. Now you can see that this work here is actually long work, right? It will be a lot worse if the number you get from here is like a big decimal numbers. Let's say it's like 7 decimal places, right? Then when you get the errors, it will be 7 decimal places. The squared errors will be 14 decimal places. And then when you divide by some ugly numbers, let's say 31, it will be a lot more decimal places. So the reason we will not use definition formula later on is because first, it's prone to rounding error. very sensitive to maybe I should not say the word. I should not use the word sensitive. It's actually may include more rounding error. May include compounded rounding error. So you round and then you round and then you round and then you round. Rounding error. Okay, so you will see we will not use this method to compute our variance. But let's see what will the formula be. Notice that we will first find the mean, right? We'll first find the mean. And once we get the mean, we subtract each data from the mean. I mean, the mean from each data, right? We subtract the mean from each data. That's how we get these errors here, right? And then we will square it. And then we will square it. And then we find the mean, which is adding all those squared errors divided by population mean. That's the variance. Now, if you compare to the formula we have yesterday, one of the formula we have yesterday, the raw data. Okay, the raw data, this one here. Definition formula for population variance in raw data, right? Okay, so you see, even though you see you have this formula, you still need to know what this means. Okay, and to apply this formula, you basically first need to find the mean, subtract the mean from each data, you square off those errors, and then get the mean. Okay, now, and like what I said earlier, this definition formula is prone to rounding error. Therefore, we will actually use another formula. Now, this other formula actually being developed directly from this formula. Okay, you need to learn summation notation. And manipulate that. Manipulating. Okay. And you will see we come up with this formula. This formula seems to be more complicated, but it is a lot more efficient. You need to memorize this formula though. Okay, you need to memorize this formula. And of course, more importantly, you need to memorize how to use it. Now, even though this formula seems to be a lot longer, it's longer than the definition formula, this is the computation. But when we use it, it's a lot simpler, okay? Because in this formula, there are actually 3 ingredients. The first one, the n, the population size. The second ingredient is the sum of x. Notice that this sum of x is one of the ingredients we use to find the mean. Okay, the population mean, for example, is the sum of x over n. So even if you use the definition formula, you still need to compute this. The definition formula, right? You have a mu very, very early, right? Okay. Now, for you to compute the mu, you need to get the sum of x, right? So even when you use definition formula, you need to compute this sigma x anyway, the sum of x. And then, so you need the n, you need the sum of x, and the third ingredient is the sum of x squared. the sum of x squared. So if we look back to that example, suppose we have that population. Okay, now clearly here the n is 5, right? The sum of x is 106. Now I want you to compute for me what is the sum of x squared. The sum of x squared will be, use your calculator please, that's 23 squared plus 19 squared plus 24 squared plus 21 squared plus 19 squared. 2,268. Can anybody else confirm? I can use my calculator, but I'd rather you do it for me. Can anybody else confirm? Okay, good. So I have 3 people get the same number. Now then using these 3 numbers, you get sigma squared equals to the population variance is n, which is sample size, population size, times the sum of x squared 2,268 minus the sum of x, which is 106 being squared, over the n squared. Okay, now then you use your calculator. Okay, I assume you will use TI-84, so I will just use TI-84 showing you. Give me a second. Now, I actually prefer you to do it in 2 steps. So I will compute the numerator first, 5 times 2,268 minus 106 squared. Get the result. And then whatever the result, divide by population size squared. I get 4.16. And notice that this is the same number we get earlier using the same population data. Okay, the result's supposed to be the same. Now, the thing is, if you do rounding too early using the previous formula, if you have rounding here too early, then very likely you have a lot of compounded rounding errors, right? While here in the last formulas we have, even if we do any rounding, it will be on the last step. You see what I mean? Okay, even if you do rounding, it will happen only at the last step. And that makes the computation, even if you use computer, a lot faster. Now, of course, with only 5 data, you don't feel the difference, right? But once you dump the computer with, like, let's say 3,000 or 4 million data, and you will start feeling the difference.
How will we know which formula to use?
A computation one. Always use the computation one.
Okay, okay.
Yeah, it's a lot faster. Okay, it's a lot faster. Now, I know some of you don't have the TI-84 yet. If you don't have that TI-84, please download it from the TI-84 emulator. I think I show you on the first day of class. So you look for TI-84 emulator. And I think you will get to the website at ti.education, something with education. And you can download the software that emulate your TI-84 calculator, at least for now. Okay, at least for now. Now, the thing is, if you use your calculator, you can actually find those numbers faster. I still need you to show the work like the one I showed you earlier. Let me say it again. I still need you to show the work like the one I showed you earlier. But using calculator can confirm the answer. Okay, now how to do that? You go to stats and then one edit. Oh, I have some data there. Let me clean it up first. Let me clean it up first. Second, oh, no, not second. I go to stats. Clear list one to clear, list two to clear. Okay, so when I go to stats and edit, I see the empty list. So I will use L1, the first list. And the data was, what is the first number again? 23. So, oops. .3. And then 19, enter. 24, enter. 21, enter. 19, enter. Okay, but because the data only 5, right? Okay, so I understand that if you are repeating this class or you took this class somewhere in high school and you were told that you need to use TI-84, which I do, I wanted to use TI-84 also. One thing I avoid is like teaching you too much into calculator such that you cannot use other software. In fact, if you need to know what software to use, you need to learn how to use Excel. Okay, don't depend too much on TI-84. Okay, now, but if you have only 5 data, I think it's reasonable, right, to use a calculator. Okay, which I taught you earlier to use to compute it manually. So using the procedure I showed you earlier, you still can use Excel to compute that. Okay, now, but if you have 5 data, you can confirm, let me say it again, you can confirm your answer by you plug the numbers into your list. See the recording of this video again to see how to plug them in. Okay, and then go back to stat. This time go to calculate, and then you will do this one far step. Are you within my calculator view? Yeah, you're at my calculator view. Then you click this one far step. One variable statistic. Okay, now the list will be L1 because that's where I put it in. Okay, and then go to calculate. And you see X bar is 21.2. Even though the thing is your calculator actually don't know if this data here is population or sample. Okay, the thing is the way we compute sample mean and population mean are the same. So your calculator will give X bar, while later on we will write instead we will use mu. Okay, and then the sum of x, we have that's 106, and then sum of x squared is 2268. Now, then you see here we have Sx and sigma x. Sx, that you will see that later on, that represent sample standard deviation, and sigma x here is population standard deviation. Okay, now, let me screenshot this. Let me screenshot that. So you see the mean is, because of the population, it's the mean. Okay, they are the same computation anyway. Okay, and the n, they use lowercase n, but because we know it's population, we use capital N. So even if you use calculator, you still need to do some adjustment. Okay, the sum of x is here, the sum of x squared is here. Okay, now notice that we get sigma squared, which is the variance. Okay, this is the sigma, that's the standard deviation. If you take this number and you square it, you will get this 4.16. Actually, we can go backward. The standard deviation, population standard deviation, is denoted by sigma without square, okay, which is basically the square root of sigma squared. That's in this case the square root of 4.16. Now you can use your calculator to do that square root. So 4 square root of 4.16 is the same to what we have earlier, 2.03961. You see that? You will get this. Sigma equals to 2.03961. Okay, now this is what I want you to do during this. I want to give you a break together with some example. Let's call this example 2, and this is a population. Let's say we have, can 5 or 6 of you give me the age of your parents now if they are still alive. The ages of your parents if they are still alive. My dad is 70 years old. My mom is 66. Okay, can 2 or 3 of you give me more? A random number. You don't need to give me the real one. Somebody say 56, 43, 43, 56, 43, 43, 45, 48. Okay, I need to stop somewhere. 63 and 69. Okay, now let's just use this. Okay, now and then I need you to find the n, the sum of x, the sum of x squared. You need to do this trio first, and then find the population mean and population variance. And then once you're done with the computation, you find the population standard deviation. Okay, I give you a 10 minutes break together with this. So let's say right now it's 9:01. So we come back at 9:16. I know some of you still working on doing your break. I will start working on this anyway because it takes me another 5 minutes or more to work on this. The n is the population size, it's 9. Now, and sum of x is the sum of all those data. And then when I use my calculator, the sum is 503. Actually, at this point, I can find the mean already. That's 503 divided by 9 is 55.88889. 5 decimal places. Okay, and then the sum of x squared is each data up there, data squared, and then you add them. When I computed it, I get 20,149. So the population variance will be 9 times 29,149 minus 503 squared over 9 squared. that give me that gives me 9,332 over 81 as 115.209.876. So this is 8. And then the square root of whatever number I have give me 10.73359. Again, when you do rounding, round it to 5 decimal places, even though when you use your calculator, you may try to avoid doing that rounding. Now then, what happened if, you want to screenshot that first? Yeah, what happened if the data provided to us is actually not in raw data? Suppose the data provided to us is group data. Let's see, from my old test, let me grab my old test. Second, I want to grab this one. I think we did this yesterday, similar to this yesterday. Suppose we have this example now. Call this example 3. And we want to find, suppose this is the population. For standard deviation, that's basically the square root of the variance. It's just like variance, it's hard to interpret. So the square root of that is further harder to actually to interpret. We can interpret the mean. Yeah, we can interpret the mean. The further interpretation of that sigma squared and sigma, the variance and standard deviation, I think I will provide that to you tomorrow. Okay. But for now, it's very hard to see the use yet. I prefer to do it this way. Like today, I will do all the computations, and then tomorrow we will do. We will touch base a bit on how to use those numbers. Okay. Now, suppose coming back here. Suppose this is population, and this is group data single point. Right, this is group data.
Papa, can you fix the water tap?
Group data single point. My son asked me to play with him. I'm sorry, single point. And the formula for the mean, the formula for mean is the sum of fx over capital N. The formula for computation formula for population variance from group data single point is n times the sum of fx squared minus the square of the sum of fx over n squared. So from here, you see that we need three ingredients. First, the n, which is coming from here. Okay, next, the sum of fx, as you have seen yesterday, we actually did it here. That's the first extension, if you remember, right? And then the third ingredient we need is the sum of fx squared. That's the second extension. The second extension consists of, we do the x squared, and then multiply by the f. Okay, this is the first extension. This is the second extension. Now, this green part here will be the sum there. Okay, now I want you to copy this table and then work it out whenever if possible. We can do, I can give you the capital N now. What's that? It's 12, say that's 20 here. Okay, now the fx means f times x, that's 12. The x squared here comes from the x being squared, that's 36. And this part here is f times x squared, 72. Maybe I use a blue color. So this 2 times 36 give me 72. Okay. Keep in mind, fx squared is not the same to fx being squared. Be very careful with that algebra. Okay, no. This fx squared here is not coming from 12 being squared. No, it's not 12 being squared. 12 being squared is 144, not 72. Now this 72 comes from the frequency times x squared. Okay, now I want you to finish this. And then use these three numbers, the yellow one, the blue one, and the green one to find the mean and the variance. Okay, let me give you 2 or 3 minutes for this. Okay, let me start. This will be 28, 48, 45, 30, which if I add, I get 163. So actually at this point, I can compute the mu already. The mu, the population mean, is 163 over 20, which will be 8.15. Now let me go on. This is 49, 64, 81, 100. Then multiply f with fx squared. So this will be 4 times 49, 196. 6 times 64, 384. 5 times 81 is 405. 300. Using my calculator to add. I get 1,357. So the population variance will be population size 20 times the sum of fx squared, 1357, minus 163 squared over 20 squared. 571 over 400. I get 1.4275. Now then, the population standard deviation will be the square root of that number. Which is 1.19478. Now, suppose we use our spreadsheet to do this. Suppose we use a spreadsheet to do this. Let me get my spreadsheet. So Excel. Suppose we use Excel to do this. Let me enlarge this so that it's more visible. So this is my X, this is my F. That's the first two columns that the frequency distribution that I give you usually. Right. Let me just do this one all in center. Now then, what is the first data? Can anybody help me? The first data is 6, and then 7, 8, 9, 10. The frequency is 24653. Let me make sure you're actually looking at my spreadsheet, right? Yeah, you're looking at my spreadsheet. Now then, then the next column is fx, the first extension. The second column is x squared. The third column is the second part of second extension is fx squared. Now, using Excel, you can do it quite fast because when it comes to Excel, you actually apply formula. Okay, if you want to see details, then you go to YouTube. Okay, I teach you the basic one here. Okay, so this cell here will be this 6. I don't type the 6, but I type the position, A2. You see, this is A2. I just moved the cursor actually, times this guy. Okay, and then for x squared, this is equal to this position is the x being squared. You see that? And this guy here is the frequency multiplied by the x squared. Now, the good thing with Excel is you can actually copy this. Well, you can get it a lot faster, and you can get the sum. The sum here, you can type the formula equals to sum parentheses, and then you highlight the place that you want to add. Okay, and you can copy this. Okay, you can actually also use auto sum. This one here. Okay, so suppose I want to use auto sum for this guy here. I press auto sum and then highlight the region that I need to add. Okay, so you see, using Excel is a lot faster. Okay, and during the test, if you want to use your computer, so you need to have your phone with video and audio facing you, right? But if you have your computer and you want to use your computer to do this, go ahead. Okay, to be honest with you, I don't want to be too strict with like the cheating thing. With the 2 hours time I give you, if you try to cheat, you actually waste time in cheating, and you won't be able to finish your test. And those who are complaining at that time that I don't have enough time, very likely the ones who, I don't say all, but very likely the one who are actually doing something else than doing the test. Okay, that's for this. How about if we use calculator? See, I teach you too much, and I hope you don't get confused. Let's see, what if I use calculator? Let me first clear up that list first, the list column 1 that I had earlier. So I create the list. Let me make sure that the list is clean right now. Okay, so the data are 6, 7, 8, 9, 10. Now then go to your L2, the second column, write down the frequency. The frequency is 2, 4, 6, 5, 3. Now then, you go to your L3. Now, then you move the cursor to up here, okay, and then you type L3 equals to L1 times L2. Boom. And then go to your L4. L4 equals to L1 being squared. And then your L5, the fifth column, will be the frequency coming from L2 times the x squared coming from L4. Now then you copy this data here. You copy this data here to your spreadsheet that you have earlier, my test. Okay, if you want to use your calculator. The weakness of using calculator this way, you will not be able to find the sum. You need to find another way to find the sum. Okay, the sum for L2, the sum of the frequency, the sum for L3, sum of fx, right, and the sum of L5, which I think you can actually do it this way. Calculate one var stats, L1, actually not L1. You want to get the sum for L2, so L2 you get the sum is 20 for L2, right? And then if you want to get the sum for L3, the sum for L3 is 163, and the sum for L5 also. Okay, but using calculator, you will get slowed down.
So, Professor,
Uh-huh.
for the test, is it okay if I like just stick with the whole like what I'm looking at right now? Can I stick it with that way instead of like the calculator or anything like that?
Yeah, I still need you to show me this thing. I still need you to show me all this.
Oh.
Yeah, I still need you to show me all this. Okay, I still need you to show me all this. But how to get these numbers, either you use your calculator. If you have a regular calculator, not TI-84, not TI-83, then you basically need to do this manually. Okay, if you have TI-84 or TI-83, you can use the way I showed you earlier. Okay, to get this. Don't forget that I record this, right? So you can watch the recording to know how to use that. Or if you have computer and you know how to use Excel, go ahead to use your Excel. But this is what you need to show me on your paper. how to get these numbers, either you use your calculator, you compute that manually, or you use Excel, up to you. Is it okay?
Yeah.
But I still need you to show me this. Now, let's go on to the next one. What happened if the data, the population data provided to us is in group data interval? Let me grab this thing. I thought I had that earlier. One second. Oh, sorry. Where did I put it? I tried to get my old quiz. Sometime. Suppose we have this. So this is a group data interval. Then how do we find the mean? I think the mean is something we have done yesterday, right? The sum of fx sub I over n, and the variance, that's n times the sum of fxi squared minus the square of sum of fxi over n squared. So here's the thing though, if you try to use calculator for this type of question, you would spend too much time, in my opinion. It will be a lot faster if you use Excel. Okay, why? Because the first thing you need to do is actually the xi, the midpoint for each. Okay, you do the xi first, and then after that, fxi, right? That's to take care this guy and this guy. The n is here, right? And then you go on xi squared f xi squared. Very similar to the earlier extension. Okay, let me give you maybe 5 minutes to do this. Okay, this is what I have. Yeah, this is what I have. What I will do next in the next 15 minutes is to apply a similar but not the same formulas into sample variance. Let me copy paste what I had yesterday. Screenshot. What we had yesterday was this is what we had yesterday. Now, for sample, the formulas for sample variance raw data is S squared. The definition formula is the sum of x minus the sample mean, x bar, not mu anymore, mean squared, divided by, now the n usually becomes lowercase n, right? Okay, but when it comes to sample variance, it took them a while to figure out that it is, if I have sample, it will be a lot more accurate if I divide by n minus 1 instead. Okay, so please pay attention to this change here. Okay, now the computation formula, still very similar. Instead of capital N, instead of capital N, instead of capital N, that will be lowercase n. Sum of x squared minus the square of the sum of x divided by n times n minus 1. So again, please pay attention. It was n squared. Now it is n times n minus 1. Okay, notice the change. Notice the change. Now, I still need you to, if possible, memorize the definition formula, but the one for sure that you have to memorize will be the computation formula. Even though I know if you have a cheat sheet that I don't know, you will be able to use that, but it will slow you down. Trust me, in your test, you will get slowed down. Okay, now, and then let me go on. Then how about the sample variance for group data single point? The variation will be very similar to what we did yesterday. For group data single point, I insert the frequency after the summation notation. And for the computation formula, the same thing. M times the sum of f x squared minus the square of the sum of fx over n times n minus 1. Then what happens if we have group data interval? And if you remember, we insert the what? Subscript I, right? Yeah, because we need to get the midpoint of each class first. Now, I kind of went quite slow when it comes to population variance, how we compute them, how do we use the formula. Now you will see, as long as you memorize the formula for sample variance, then in practice they are very, very similar in applying. Okay, let me give you a couple more seconds, let's say half a minute, to copy this down. If you want to copy this down, but you know we have this yesterday, right? I strongly suggest you to do this thing though. If you have printer, right? If you have printer, then all the lecture notes that I have on the previous day, print it out. You know, instead of just leaving them online, right? If I were you, I would print it out. Now then, how do we use this? Notice that, let me scroll it down. Notice that suppose I use, suppose I use this again. Give me a second. Suppose I use this again. Suppose I use this again, but this time I call this a sample. And find sample mean and sample variance. Then you will see the way we work this out, the way we occupy this table is the same to the way we occupy the table earlier. So we get fxi, I mean xi, fxi, xi squared, and fxi squared. Okay, and then here we will get 32. I think here earlier we get 533, and then what's that? 9777. So the procedure will be the same. Here you get 9777. Okay, so you fill this up yourself. Okay, you fill this up yourself. Let me write it down. Do it yourself. We have done that earlier, right? Okay, so then if I need to find what is the sample mean, the sample mean will be 533 over 32, right? You can compute it yourself. Now, how about the sample variance? Sample variance denoted by lowercase s being squared. This is a lowercase s. Okay, and that is equal to, if you follow the formula I give you above, that will be 32 times 9,777 minus 533 squared over 32 times 1 less than that. Now, if you compare to what we have earlier, let me scroll up. Notice that the formula is very, very similar. In fact, the numerator will be the same. The numerator will be the same. The difference is at the denominator. Instead of 32 squared, instead of 32 squared, we will have 32 times 31. Okay, but the numerator is the same. Same to population case. Okay, this is where it differs. Then I will compute. I think for the numerator, I have that up there, 28775. So this is 28775, but the denominator will be 32 times 31. That's 992. I get 29.00706. Therefore, the sample standard deviation, this is sample standard deviation, is just like before, the square root of the sample variance. So you will see this note here. You will see this note here. The population standard deviation is the square root of population variance. Sample standard deviation is the square root of sample variance. Okay, in other words, the standard deviation is always the square root of variance. Okay, that's a little note. So now I will do the square root of that. I get 5.38582. Okay, so the homework, which I call quiz 1, that we'll do on Monday. So you have a couple days to work on that, right? I strongly suggest you to work on that earlier, such that you don't wait until Saturday or Sunday to work on that. You may forget already, and lose track. So I strongly suggest you to start working on that, and then turn it in once you are done. Okay? Yeah, but I need you to do your quiz 0 first, though. Okay? Do your quiz 0 first. That's the extra credit. If you don't want to do extra credit now, don't ask me for extra credit later. Okay, and I don't do more extra credit. Whatever I give you, that's what it is. And if you don't do well at the end of this summer, I don't expect you to come to me. Please don't come to me and ask, what else can I do to get extra points? That's too late. Okay, no, that's too late. But Thomas, I need to transfer. That's everybody's problem. Okay, now, hold on, somebody LOL. It is true though, like, you know, I learn stats, I teach stats, so I use statistics, right? Okay, please don't use a reason as if that reason only applies to you, while it actually applies to everyone. Okay? Yeah. And from no, when I say you LOL me, not in a negative sense. I'm glad you get my sense of humor. If you are in my class, I have a lot more jokes in which I use statistics. One of the things that I use in my class quite often is this. You know, some students come late, right? Some students usually come late to class, right? And when they come late, they use this reason. Oh, Freeway 10, it's traffic on Freeway 10. And I say, well, I use Freeway 10 too. And Freeway 10 has had traffic at 8 o'clock in the morning since 20 years ago. So you do not use a common knowledge as an excuse for coming late. In fact, I live in Monterey Park near East LA College. I live like a couple blocks from East LA College. And I need to drive through Freeway 10 and go through that traffic for the last 13 years since I was hired. You know, and then you come to me saying that, you know what, it's traffic on Freeway 10. Dude, everybody knows it will be traffic. Because you know it will be traffic, don't use that reason. Find another reason, okay? Yeah. Well, anyway, yeah, we all, man, LA at Freeway 10, especially if you are so so unlucky that you need to use freeway 4 or 5 in the morning. Oh man, that's humongous parking lot, right? Well, I need to go back to this though. Couple of things to really to mention further. That standard deviation, variance, and variance either population or sample, and therefore standard deviation either population or sample, based on the formula, will always be non-negative. So once you get your variance to be negative, something wrong with your computation. Now, instead of using a word node, let me make it a bit harsher so that you are aware, so that not that trying to be harsh on you. It's like, be aware, then do not continue with your work if you get anything here to be negative. The mean may be negative. The mean may be negative, okay? But the variance and therefore the standard deviation can never be negative. In fact, to say more, the variance or the population variance or sample variance equals to 0 only when there is no variation at all in the data. Suppose, for example, the data set is 40, 40, 40, 40. Now, the mean will be 40, right? Okay, but when you compute the samples variance, you will see that 0. There's no variation. There's no variation. And therefore, the sample standard deviation will also be 0. That's the only time the variance and therefore standard deviation will be 0. Okay, once you have a little variation, then the variance will be positive number, not 0. Okay, but under no circumstance, the variance nor the standard deviation will be negative. Okay, what we will do tomorrow, we will see some application of this mean and standard deviation, how to use them. Okay, and then I will go on with a quartile system. So if you read, I think if you read section 3.1 or 3.2, 3.3, you will start seeing quartile system. That's measure of position supposed to be. And also we will learn how to construct frequency distribution. So suppose we have raw data. How do we even come up with this? Okay, if we have raw data, how do we come up with this? We will learn that tomorrow. And of course, more things to say, but at least from what we have learned so far, what we will do tomorrow, you can imagine that. Let me see, you have some. I don't see the homework, how to get there. Good question. So to get to the homework, you go here, go to assignment. Now then you have that quiz 0, right? So you have that quiz 0. Now I will post the quiz 1. Let me do it now so that I don't forget. Who did that LOL on me? How do I erase this? Whoever did that, please erase this. Okay, quiz 1. Let me post it here. And the way you do it is the same to the way you did your quiz 0. Okay. Give me a second. Let me post it now. Do as you did your you did quiz 0. There will be 10 points. that in as the homework group. And then the file uploads only PDF. No pictures. I don't want pictures. And then when will that do? What time do you want that to be due on Monday? Before class? I think that's fair enough, right? Maybe 8:05 a.m. Is it okay?
806. 806.
8:06. Okay, 1 minute. 8:06. I'm nice enough for 1 minute. Okay. Statistically speaking, you have thousands of minutes between now. Nah, not 11:59, and then you will push it to June 23rd. No. I need you to be done with this by the beginning of Monday. I think you have enough time, right? Okay. 8:06. Oops. Okay. This is 8:06. Now, when I say 8:06 here, it means you need to fully upload it. Not when you start uploading it. Your file has to be fully uploaded by 8:06 and already submitted by then. You have to submit this assignment by June 22nd, 8:05:59 in the morning. 8:05:59 in the morning. Once the time is 8:06, then the system will reject that already. Okay, please be aware of that. Let me turn it in. Save and publish. Boom. So you should see that on yours right now. Okay, is there any practice set to do? Any homework assignments or quizzes? You can see from my old quizzes in the past from my website. Okay, if you want to do more, but the one you need to turn in only the one I put in the assignment. Okay, and for your homework, I always let you know more than 24 hours in advance. In this case, it's like more than 100 hours in advance, right? Okay. Well, by the way, tomorrow we still have class. Not that we don't have class tomorrow. Okay, we still have class tomorrow, but you can start working on that quiz 1. For those people who have not done quiz 0, please do that first. Okay. Other questions?
For quiz 1, do we have to like have a show ourselves?
Louder, please. Speak to the microphone.
For quiz 1, do we have to record ourselves, like have the video on, or no?
Oh, no need. It's homework. For even though I call that quiz, right? Consider that as a homework. No, you don't need to record yourself. No.
Okay.
Just like the way you did your quiz 0.
Okay.
Okay. Mm-hmm. Other question?